Guys, let's continue with the next part. So, what's the plan for today? so, there's some more new concepts or new topic we are going to start, right? It will be a little bit very different topic. Again, obviously, it is a part of AWS only, but the flavor of this topic and the use of this topic would be a little bit very different. Okay, so let me guys give you the name and the agenda for today. So today we are going to start one new topic called Athena. So Athena is the one more topic that we are going to discuss today. There is one more service that is again somehow integrated with Athena. That is called Glue. Okay, Glue is a big service. So technically, I'm talking about Glue data catalog. Okay, so there's one more service we have. So what service 1 and service 2, and so these two services somehow link to each other. Okay, so this topic, these services we are going to deal and discuss today. Okay, but this service, guys, is somehow related to and useful for S3 as a storage. Okay, and way we manage the data in the S3. Right, there's one more very interesting concept called partitions or prefix in the S3. It will improve the performance of S3 that we also discussed today. Okay, and maybe something related we are going to discuss today is CloudWatch log. Okay, so independent service. Okay, but maybe somehow we can also integrate Athena with CloudWatch log. Okay, so these are services, and when I go for this topic, so it will also help us to understand what is SNS. So SNS we haven't discussed yet. I introduced you very high level in some of my classes, but I haven't explained you the use of SNS. Okay, so because maybe I might be waiting for this particular topic that we are going to discuss today. So it will also help you to understand the SNS or maybe CloudWatch alarms. Okay, so lots of things, a lot of plan we have in the today's class. Okay, so let me start one by one about this particular topic. Okay, but typically these are our services, right? I'm already in the portal, and if you search, we have Athena? So yes, we have Athena. You can see something related to S3. Do you have a Glue? Yes, also we have a Glue, something like ETL services, but the service is also here. Obviously, do you have a CloudWatch? You guys know CloudWatch. Sometime we all discussed. We have CloudWatch log also, part of CloudWatch. This is also one of the service we have. Okay, so multiple things we are going to discuss today. So let me start in this way. But guys, again, I would like to tell you one small thing before we start. By chance we into a CSA training or in the developer training, we have very small discussion of 1 minute in CSA about Athena, and I believe there's no discussion about Glue as such in our program. Okay, but even though as I did always, even though I'm trying to touch as much as detail with the practicals about Athena and the Glue data catalog. Okay, so that you can get the idea and the power of this particular service. Okay, same the CloudWatch log also. Very quick discussion we have actually of the CloudWatch log. Not as such a detailed practical, but I'll try to show you how CloudWatch log work, how to practically implement, plus how to integrate the services like Athena. So those kinds of things, guys, we are going to discuss. So there's no, as such, we don't have in a program on CSA developer, but as an AWS engineer or as an architect or as an associate, okay, because while you're here, maybe most of you guys have a plan for go for AWS CSA global examination. Okay, so the content that I'm delivering here would be more than enough to pass the examination, but my goal is not that one. Okay, because getting certificate doesn't help you to solve real use cases. Okay, because finally you have to work for the company, right? So for this you should require a practical knowledge. Okay, and that's what I'm trying to deliver here. But if you want to know much about Athena and Glue and these kind of services, so they have a specialized program in AWS. There's a one new program they launched. It's called Data Analytics. Okay, because this service is more about analytics services or big data services. So they have one advanced program from AWS where they talk more about Athena and the Glue. Obviously, in this training, I won't go for that detail, but at least some of the practical I'm going to show you, so you have a quick idea and detailed idea somehow that how these services work and which kind of use cases this service is gonna solve for you. Okay, so anybody who are interested in big data or big data ecosystem, anybody who are interested in analytics services or analysis maybe, so these are services are more related to analysis and analytics services. Okay, so let me start start from very basics about what Athena and what Glue will do for you. Okay, so let me start in this way. In this way, for example, in our company we have a different departments. Okay, every department, for example, we have HR department, we have R&D department, we have technical departments, and hundreds of different departments. Okay, every department has their own apps, applications, mobile application. They have their own portal. Okay, own data. Okay, so technically, what I'm talking about, every department in our organization, they everyday basis they keep on generating a lot of data. Okay, for example, in technical department they have a website, and obviously website host on the web server, and any of the client who hit to this web server. Okay, so web server will will create a data, and that, guys, here you guys know it is called logs. So they generate the log. Who generate web server? But where web server run, we run on the machine. So it is also known as machine generated data or machine data maybe. So log is one of the example of machine data. Okay, and log, obviously, guys, in the web server, web server, this log stored the information which page we access, from which client IP we access, from browser which access, which time we access, right? So logs is a file where we create a log, means the information about that particular request to the web server. So pretty simple. I think you know this concept. Okay, so this is one of the example where this particular department, okay, generate data from their web server. But likewise, they have their own internal portal, they have own reporting system. Okay, hundreds of things or hundreds of different data they generate. Okay, now technically, if you try to understand any log, and guys, if you ever see any log file, normally typically log file would be something like this. Something like this. Okay, so if I type here, so log file say at this time, okay, then from this particular IP address, okay, somebody access this particular page, and this page will exist. So we have a success message called as a 200. Second client come up from this particular IP address, they want to access this particular page, right? And this page was not by chance exist in my server, so we have 404 error message come. So typically this kind of log files we have, where we keep the information about what happened in our historical or what happened in the past. Why? One of the reason is this information we will use if some hack happened, somebody try to attempt our, try to hack our website, so we can go see the logs and see from which IP we get a lot of requests. We get a lot of requests for different pages or different attacks. So we'll analyze this file to try to find out or to try to backtrack what happened in the past. Or maybe there might be other reason, maybe okay, reason maybe maybe my company want to analyze which page we has the maximum request per day basis, which page we have mostly get 404 error. So we can ask our developer why this page client is coming but is not exist, or because it not exist. So do something, because having 404 error showing to the client is not good for the company reputation. So either create this page or redact this page to home page or do something else. Or because this page having more requests, so so try to optimize this page so my client will have a better user experience. Or provide some extra resources to this file in the terms of RAM and CPU. We have some way so that the performance of this page will increase. So lots of things they need to improve in the future and want to do in the future. That is the reason we normally create a log. So I believe you guys know this. Okay, but main point, guys, here that I want to emphasize over here is 99.99%. Okay, whenever you generate a log or create a log, or not only log, mostly maybe some other data. Maybe my company want to store some information. Let's say they want to store some ID one, then they want to store some name. Let's say they want to store some remark. Let's say, okay, second user, your name is Jack and their remark is good. Third user, their let's say name is Chris, remark is again good. Okay, so they want to store this information about the clients or their vendors or maybe of the employees, and they store this information somewhere in some document. Okay, so mostly the way we store data in a file, typically this file is also known as data set. So where the data where we store in our data set, okay, 99.9%, especially in log perspective, we never store the metadata of this data. Okay, what I mean by this? So if you see here, if you know about this data, then you come to know, hey, I know this is ID, or I know this is a time, or the date. I know this is IP address. I know this is a web page they're looking for. I know this is the status code or the byte transfer. So technically, if you know who create this file, or if you know anybody who know about Apache server or any server or web server, they know what this field is all about. Okay, but normally we don't, because we don't store any column name. Column name here, for example, this is status code. So this is called column name or field name, or or I can say the metadata. Okay, so normally in a logs file, especially, okay, 99.9%, guys, any of the web server or server services you worked on, you never see the file or the log file where we store our data. Okay, we never store, there's multiple reasons for this, but we never store the field name or the column name. It is also known as metadata of this data. Okay, we only store these information, or maybe we only store this data set. So anybody from machine learning background over here or deep learning, so whenever, guys, you work on data set, you will see 99%, right, or more than 99%, whatever data set you get from somewhere from the Google, you will never see metadata in the file. Okay, there's no column name in the file. Okay, and this kind of data, guys, is known as raw data. Okay, why they don't have is not the important point here for today's discussion, but they don't have, that is an important point here. Right, so this kind of data is called raw data. Okay, and normally in the company there are lots of raw data we have. Every department generate from the machine, from the app, maybe handwritten, they generate every day. Okay, and this data is so huge. Okay, and that is the reason, guys, this data is known as big data. So every company has a huge big data every day basis they generate, but they want to keep this big data somewhere. Obviously, we want our data to be stored somewhere. So in the future, we can do some analysis on the top of the data. And for this, company has some storage. This is called big storage or big data storage. Okay, typically it's known as data lake. So data lake is one big storage in the company. And the motto of this data lake is to store big data. Data means all the raw data, whatever the company's other application is generating. Okay, so the motto of this data lake is to store all the raw data, but which data? Where we want to do some analytics. Okay, why we create a log? Because I want to do some analytics on the top of the log. I want to see today how many times we get 404 error. Okay, tell me the count. Today, how many clients hit to my server? Tell me the count. Okay, today, can you tell me tell me how many employees we have a remark good or comment good? Tell me the count. or tell me the total comment come today. Okay, guys, this concept is called analysis, right? So, so if you want to analyze something, okay, so if this is a case, okay, so we collect lots of data for different department, different apps, different services, and we store all the data in one centralized storage, because this storage we manage for big data, and motto is also to store all data in a raw data format. Okay, so that on the top of this, we can analyze this data. What I mean by analyze, in a minute we'll discuss. And if this is the case, then this kind of storage is known as data lake. It is not known as database, because the motto of database is very different. Or motto of RDBMS or NoSQL is very different. Here, or motto of data warehouse is also very different. Okay, so we have a lot of different storage available in the market. Every storage have a different use case. So if your use case is data is big, huge, big data, and you want in the future, or all the data is called normally raw data, you want to do some kind of analysis on the top of this. If this is a requirement, then this storage is known as data lake. And if you want to create a data lake, so a lot of products available in the market in the big data world, this called big data ecosystem. One of the very important famous product in the market called Hadoop. Okay, and Hadoop has one cluster way. It's called distributed storage cluster way. It's called HDFS. Maybe a lot of guys might know, or especially the Earth guys, the student, they know. We have discussed HDFS already. So HDFS is a technique or a program through which we can create a data lake. Okay, but Hadoop is a open source tool. Okay, open source tool, and we have to configure it ourselves, and we have to provide our storage to create a cluster. Okay, but if you go to AWS and say, do you have any data lake for me? Do you have any big storage for me where I can store all of big data? Size will be maybe terabyte and petabyte in size. Okay, I can store all of my raw data and raw file, so that in the future, after I stored my data, okay, data store in you. So in the future, I will come and do some analysis on the top of this. And understand, guys, big thing is the important thing to be noted here. Okay, I want such a storage where I keep my data, the scale of the size of the storage, maybe in petabyte or maybe yottabyte, maybe okay, but typically in petabyte normally. So that kind of big storage I need. Okay, and second thing is, why you're storing this data here? Motto is I want to maintain my historical data, keep my history, right? What happened in the past, and why I want to have maintain your history or historical data, so that in the future, maybe per day basis or in the future, I can come and analyze this data. And understand one thing, guys, if you want to analyze your data, you need to run a program. Either you run the program, or you can use some third-party tool, right, to analyze all your data. Analysis, again, I told you to sum, count, group by, aggregate, lots of things there in the analysis world. Okay, so that will be a different point. But if you want to analyze, if you want to run a program or a tool, you need data. But this data is so big, okay, like in terabyte. So if you want to analyze, so it is very harder to transfer this data to this tool, because if you want to run a program run on the RAM, and if you want to analyze something, okay, the entire terabyte data you have to load on the RAM, and obviously that much size of the RAM might not be possible at that point in time. Okay, so we have to create a setup in such a way, okay, where I want both the things will be solved. Okay, I can get this data lake where I can store petabyte data, and I can also solve my use case that I can use some program and tool that help me to analyze, and without transferring this data to this program or to this third-party tool, okay, this storage I use, and I do all the operation on this storage, and finally I will get my result back to this program. That's also my requirement. And so for this, Amazon, guys, has a huge interesting integration of multiple tools. By default, they provide you in a cloud, and there's a managed services, so you don't have to worry about the provide to you. So first of all, guys, this data lake that I'm talking about, that is a huge big data storage. So Amazon has one service that will help you to create data lake, and you know, guys, the name of service called S3. So S3 is your object storage, but it is it all the property that we need for the big data storage S3 has. And one of the big important property, guys, big data lake need is a scalable. So they say we have a almost like infinite is storage available. Your data size will be terabyte, petabyte, yottabyte. We will give a storage to you. And second thing we need the data that we write and read is called IO operations or IOPS. I already discussed, guys, in my last class, or throughput. So I want this thing very faster in terms of read and write. So S3 is one of the fastest storage AWS provide to us. Depend, guys, which storage you want. In the last class we discussed about multiple types of storage we have or classes we have. You want to go for standard or IA in frequent access or some other storage, that would be your choice. Okay, but S3 is a great candidate of great services to create a big data storage. So anybody who know by chance Hadoop and they know HDFS, so if you set up Hadoop on the top of AWS, there you have two choices. You want to use HDFS or you want to use S3. So both the guys you can use to create a data lake. Okay, a recommend perspective would be, in the AWS perspective, we always wanted to use S3. Okay, so that is a recommended one service. But if you want to use HDFS, then you have to configure by yourself. That is a different point. Okay, but the conclusion here is, if you want a big storage or big data storage, it's called data lake. Then S3 is a service. Okay, but what is this tool who helped me to analyze the data and without leaving the data from my storage, from my S3? Understand one thing, guys, very common, right? If your data is in a file, okay, and obviously a file is there in the storage, okay, and if you run a program, it's called process, it run on the top of memory, it's called RAM, and if process needs some data to do something, okay, process always go to hard disk, get the data, load the data on the RAM first, then operate your process on the top of data. This is the way it works. Okay, but here, guys, in this case, if my program want to have this big data in terabyte size, if they load entire data on their RAM, okay, it will be a very costly operation and very slow operation, I can say. Okay, so I need a program here for analytics. They will go to S3, do their analysis there only, okay, and give me the result, because the result is always a very small. Your data size may be terabyte, but ask them, tell me total number of clients we have today who purchased this item. So this is what we are doing analysis. Okay, so result may be 50, 20, 100. So they will give me the result back. So that's always very quick. Okay, so the tool that I'm talking about here is Athena. So Athena, okay, this tool I'm talking about. So Athena is a tool. Okay, it is meant for analytics perspective, and they have very tightly coupled with S3. Means they are very highly integrated with S3. They know how to go to S3, process the thing there, and get back the result to you. Okay, that's the duty of Athena. Okay, so we can think Athena is a analysis or analytics tool, and mostly they go to S3. They have other way also, but they normally go to S3 to read the data. And guys, wherever you store the data, normally that space is known as data source. So for the Athena, S3 would be the data. So they support more data store. Okay, but S3 is one very commonly used data store by Athena. Okay, but Athena also have a data store from Cloud Log, maybe your other databases, right, or data warehouses. So they support other also, but mostly we use S3. Okay, this is one thing. Second thing here to be noted, I told you guys S3 is a data lake, and in the data lake we store big data, and big data we have a data that data is always 99% always a raw format by nature. Okay, and because they are raw data, it looks something like this. But understand one thing. Okay, if you want to do analysis, for example, let me let me read this part here. Okay, and if I give this information to you, or let me add one more information here, and if I give this information to you, and let's say you are the best analytics guys in the world, nobody is better than you. Okay, best programmer, best analyst guy in the world. And if I ask you one question over here, can you tell me the salary of Vimal? So what is the salary of Vimal? Can anybody tell me the answer by looking at this data? Can you tell me the salary of Vimal? Answer is nobody can, because because here I have provided you raw data. By looking at data, maybe it look like this is the information of Vimal, this is the record of the Vimal, but but I don't know. Maybe salary maybe 1 or maybe 100 in some unit, maybe million or something, whatever I have. Okay, but I don't know. We don't know, because if you want, if you're looking for what is salary of Vimal, means you're doing query, or you want if your requirement is can you tell me the average salary of my employees? So average salary means average. So this is the concept. This is the concept of analysis. So either you do query or analysis. In both the form, if you don't know this field is salary or this field is salary, nobody can tell you the answer. Okay. So technically, what I'm talking about, in your analysis tool or in query tool, okay, you need raw data, but raw data is not useful. Raw data is very important, obviously, but only raw data doesn't help you to analyze something. You also need metadata. Okay, because if I don't tell you that this field is my salary, this is just my enrollment number or ID or employee ID, then you can say, now it's so simple. It means this is your serial number, this is your name, this is your salary, right? And now this is your remark. So I can create some tool on my language, Python or Ruby, or make it use third-party tool like Tableau or something like this. And we can ask this tool that every line is a one record. Every record has a one value, second value, separated by comma. So before the comma, after the comma, field. And when you see third field, it is salary. So go and retrieve all the third field and submit and give the average. So the writing the program or using third-party tool might not be a big challenge. Anybody can do it. But if you don't know the metadata or the field name, nobody can give you the answer. It's impossible. Okay, that's the main point. So only raw data won't help you. You need metadata, and that's the challenge here. So in the raw data or the data lake, 99.99% we only store raw data. Right? And if you store raw data, so if you want to use a program like analytics tool here, Athena, they want to analyze, do something, it won't work. Because without metadata, how they analyze the total salary or total count or something like this? How they analyze? Impossible. Okay. So if you want, to analyze your data, first of all, okay, whichever data you want to analyze, you have to first create a metadata. So you have to first create a metadata and attach this metadata to that particular file. So in S3, what do we have? Object called file. What file contain? Raw data. Okay. So before we analyze with Athena, we have to create a separate metadata, sometimes also known as schema. Okay. Schema. And okay. And obviously, guys, every file has a different fields. So for this file, we create a separate metadata. For example, this file has 4 fields. So I create metadata in 4 columns name or field names. Okay. And attach this metadata to this file. Okay. So for this also, guys, we need a service. So AWS has one service, a name of the service that help you to create metadata. Again, you can think that service is known as metadata service. A name of service called Glue. Glue is actually a big service. They have a lot of components to do. Anybody who by chance know ETL operations, Glue is meant for ETL. So here we are not going to discuss anything about ETL today. Okay. So, but Glue has one component called catalog. Let's go Glue catalog. This is a catalog. This is a service who help you to create a metadata. Okay. So it's something like this. Now we have three different services. Okay. Three different services. So we store our objects, raw data, files. In the big data world is S3. This is called data lake. Okay, we'll tell Athena, go to S3, analyze. But Athena say, I can't analyze my raw data, I need a metadata. So I'll tell my Athena, do one thing, when you go for this file, okay, you will find the metadata in the Glue. Go and get from there first. Then you come to know, okay, the metadata of this guy. And after you find the metadata, then what I want to analyze or query, you can do it very fast. Okay, so it will work like this. So anybody who by chance know Hadoop world or big data ecosystem, okay, so you can compare S3 with a service called HDFS from Hadoop, or you can compare Athena with a service called Hive. So Hive is a one product or open source product in the big data world. So you can compare Athena with Hive. And not Hive, there's some more tool we have, by Presto or some more tool we have, but they can very highly compare with Hive. Or you can compare Glue or meta service with a concept called Hive metadata store. In Hive also we have one meta store or metadata part they can compare. Okay, so something like this. So you can think on this way also. The cloud is a managed service. You can think, if you want to create your own Hive meta store, rather than you create or you manage, AWS provided you Glue data catalog or catalog, where they say, I manage the Hive store for you. You don't have to worry about it. So you can think is a managed store for Hive. So Hive is a one product open, so you can also set up in your laptop. It's a software like normally Hadoop or other softwares, and you can set up. But here we don't have to set up everything; they do for you. Okay, so that's how these guys connected here. Okay, these guys connected. So so let's me do till here. Then we move to a concept called CloudWatch log. I think guys here now you can very highly link why we're using this service, because this guy will help you to fill the log in S3. What I mean by this, and after some discussion, we'll just come back to this topic. Okay, but let me first set up these three components. Okay, so for this, what I'm doing here, now let's move to practical part. I believe guys you got the idea of these three services. very much useful services. Athena is a great service, no doubt. Okay, as a higher level, bigger level, you can't compare by essence, but you can also think about this. One of the very powerful product in the market that I always recommend, a huge demand always, is called Splunk. So typically, whatever you normally do in the Splunk, you can do in the Athena. Not as such, Splunk is one of the great tool. Okay, nobody as such compare, is a unique tool in the world. But something like this we can do in Athena. But Athena is more linked with S3 or the AWS cloud services. Okay, so if you go for a Splunk kind of tool, where we have to configure the different point, because it's a different tool altogether or software altogether. But if you talk Athena, everything is managed by AWS. Okay, they don't tell you server and everything they manage internally. So I can consider Athena is a serverless service. So Athena is a one service that come into the category of serverless. Even S3 is also serverless. You never guys know where the server is, where the storage is. So S3 is serverless for storage, Athena is serverless for analytics tool, and something like this. Lambda is serverless for function as a service. So these are the serverless services by the AWS. Okay, so let me show you the practical how it works. So let me take the same example. Okay, so here I created this file. This is a raw data. Every line is a record here, and every line we have 4 different values: How? Because we know it is we put a comma. So typically, this kind of file is normally known as comma separated value CSV file. So let me save this file first. Let's say this is Athena S3 S3.csv. So I'm storing with this way in my document folder. Okay, so right now this file is in my laptop, but I can upload. We'll upload this file obviously in the cloud. Okay, so now what's the plan? First of all, I will first go to S3, okay, and upload this file, whatever file I created. And let's say this is the raw data I upload in the cloud in S3. And when I upload, obviously we have to create a bucket. So I create one bucket, and in this bucket I upload the file. So let me start from here. This part you know already, S3 bucket, but let me very quickly go to S3, create a bucket, and we'll upload that. So I'm going to create a bucket, and let's say this bucket is AWS class Athena, okay, something. And I'm creating this bucket in let's say in Singapore region. Okay, nothing is special, but I'm just randomly putting in the Singapore region. Okay, and anything else? No, nothing. So this is a bucket we have created. Okay, bucket we have created. 1 minute. Let me open your document also. AWS. Where is the document? AWS. So 1 minute. Let me guys share all the commands to you. So this bucket is created, and now let me upload. Let him load the where is the bucket? Yeah. let me guys upload my document here. Okay. Now what I'm doing here, very interesting concept, guys. I'm going to explain to you here. Okay, very interesting concept. It's more about S3. Okay. So you know what happened? If you what you guys store in S3. So let's say your bucket. Let's say my bucket name or folder name in S3. Let's say a folder name is let's say my folder name is Linux World Database. This is my folder name. Okay, and what do you do in the folder? You're going to upload a file. File is also known as object. And guys, here name of the object or name of file in AWS in S3 is also known as key. So key is equals to file name or the object name. Okay, in the S3. Okay, so let's say you store a file or upload a file f.txt, or you have one more file you upload f2.txt, or let's say f3.txt. Okay, and let's say you store everything in a bucket, and let's say bucket is using the storage class called standard. Standard is the most fastest storage class in the S3. Okay, so if you want to download this file or read this file again, or your client want to read this file in their laptop, okay, this is called get request. Means you want to get or download this file. Okay, so by default S3 guys will give you a performance or latency, okay, around 100 and 200 millisecond latency of the get request. It means something you can think of okay, around 5,000 or 6,000 okay file you can get in a second, something like this. So that much speed S3 give you. Get means you're asking them to get. Obviously, file size also matter, but the speed they get this information about file and start providing you as a download. So you can think, okay, you can think in 1 second, 6,000 file we can download in parallel. In the simplest, or maybe 5,500 around, we can see the document of S3. So, so maximum speed that you can get in S3 is around, just for example, is around from one bucket Okay, you around 5,500, 5,000 around file you can download per second. That's the speed S3 give you. Okay, but what do you store in S3? You store data, mostly your raw data. Okay, or maybe for your website you store images or videos. Okay, but there might be possibility that maybe you have more requests come up per second. Let's say you have 60,000 requests per second come. Okay, to download different files and images. This much request, let's say, come. And obviously, by the maximum speed, let's say they give only 5,500 or 6,000 per second. Okay, so it means obviously remaining request only 10% request, so you can serve remaining request of 90% it will hold. Means you ask the client to wait, and obviously, guys, we don't like client to wait for the things, right? It doesn't looks good or not good user experience. Okay, so how can you improve the performance? First thing is we can we can go to best type. And here, that's what I'm talking about, guys. I'm using this S3 standard. This is one of the fastest storage. As they provide you, and S3 is one of the fastest storage provided by AWS Cloud, guys, and one of the fastest service, storage service in the world. Also, you can think in this way. So I can't go more than 6,000 because this is the fastest things possible. Okay, so what can we do? So here, guys, we have to use some management techniques. Okay, management techniques is something like this. Now, what can we do? Okay, instead we store all the file and document in one single folder. Okay, what can we do? We can create one bucket called LWDB, and in this bucket, we start arranging the file or document or the data or the images per product basis, per region basis, per day basis. Okay, we know every day we get a request for example, if I open my calendar. Okay, so we know we mostly we get the request for 9th day, 8th day, 7th day, 6th day, and 5th day of April. So what I'll do, I create one more folder inside this folder. Let's say folder name is slide 9. It's for 9th of April. This is the 8th of April. This is 7th of April. This is 6th of April. And all the data that we collected from our customers or Intel teams, raw data, or image or video, we store here. So let's say we store all the files. Let's say file 1, file 2, file 3. Of all the files that we collected for the 9th, we store on the folder name 9th. Okay. Same thing, what a file we collected here, let's say D1, D2, D3, we store in the folder called 8. So everything is inside this folder only. So there's a main tree or top level directory or file system, and we have subfolder, 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 and per day basis we are storing and managing their file. Now it is your choice. You want to manage per day, per week, per month, per product name, per region name, per country name, per client name. It will be your way how you want to organize your data. Okay. Typically, this concept is also known as our data. All the files we have with partitions per day basis. So here we created a partition, again like a subfolder, but this world of arranging, normally in the database world or NoSQL world, this concept is normally known as partitions. Okay, so we create one partition for 9th date, 8th date, 7th date, or 6th date, and something like this. Okay, so why are we doing this? Okay, so this is the way we are organizing data. And why we are organizing this data? One of the key reason is performance. Because what Amazon say, per folder basis, because bucket is also folder, per folder basis, I am giving you a performance speed maximum this way. Okay, and I know, okay, mostly my client okay, want to read maybe 5% data from 9th day, then 8th day, and 7th day, and 6th day. So what can we do? we distribute the load. Okay, how? By creating this subfolder. So technically what I achieve, okay, now this particular folder, I have a separate speed of around 6,000 per second. This folder, again 6,000. This folder, again 6,000. This folder, again 6,000. So if you get 10 subfolder or 10 partitions, okay, so 6,000 into 10, again you got 60,000 per second speed that actually I'm looking for here. Okay, so my point, guys, here is there's a concept in the database called sharding or partisans, a lot of other concepts also. These concepts in the database and NoSQL world, we might discuss in the future classes. Okay, we meant just to improve the performance of read and write, especially read. Okay, we do this kind of management. Okay, and by this management, now my client can read parallel. Some client will go here, some will go here, some will go here, depend upon the need. Okay, and everybody can read parallel from here, here. And now depend, guys, how much parallel you can do here. By chance they support 6,000 around, 5,500 around. So that much parallel you can hear, that much parallel per second wise you can connect to this. So more partition you create, more subfolder to create, but it is your planning how you want to arrange. Okay, so you want to arrange per day basis, per week, per month. Maybe my company say I want to create a report per week basis. So there's no good reason to store one single folder for month. Arrange your data per week basis. So create one separate folder for first week, store their data there. Second folder again create next week, store your data there. Okay, so whenever the company want to create a report, we have to focus on those folder and we hit those folder or those bucket and retrieve the data from there. Or maybe same point in time, other team might require data from for different week, we go in there and create a report of that week. So it's a good concept in terms of management. And good thing is S3 support this. Okay, and guys, by chance, this concept, okay, here, so the folder 9, folder 8, and folder 7 or 6, whatever name you have created is your choice. This concept is called prefix. So this concept called in S3 world, it is called S3 prefix. So prefix is like a path. So this path, normally, guys, in our normal OS, it is known as path, but in S3 we normally use a term called prefix. Okay, and good thing is, as such, there is no limit in the prefix. You can create hundreds and thousands of prefix. As such, there is no limit in the prefix. But more prefix you have, more parallel processing you can do, more hit per second you can hit, you can do on your bucket. That's the whole and soul idea. Okay, so again, if you think for the physical hardware perspective, you exhausted your limit of performance, then the key thing that play is how you organizing your data. Okay, there's the guys role of organization and management of data. So, but for example, if you want to organize data in the RAM, the data structure come in play, how you organize data in tree or queue or graph or linked list. But if you want to organize your data in the storage to have more performance, then this kind of concept, hot bucket or cold bucket or this prefix concepts, partition, sorting, those concepts are gonna come up. Okay, so this is some extra information I just want to update you. So that's why that's kind of planning I'm doing here. So what I'm going to do, I'm going to create a folder inside the bucket, or let's say I'm giving the folder name. Let's say this is the April month, so I'm storing my data per month basis. So this is the folder I'm going to create. It's just a folder, and you can do per folder by the encryption. So I can say all data in this folder I want to encrypt, or next folder I don't want to encrypt. So we can do per folder by encryption also. So this one here, I'm not doing any encryption. Great. Okay, let me create one more folder. So I'm going to create a folder called May, for example. I want to store May data over here. So 2 folder we created. 2 means 2 partition we created, or 2 prefix we created. Okay, so this folder has their own speed, let's say 5,500 per second. Again, this guy also has their own speed. So in totally in this bucket, we have 5,500 into 2. This much speed we're gonna get it. Okay, so that's what the planning is. And I know what I'm doing here, nothing special. I'm just going inside this folder and upload my data here. So let me upload. Okay, add, and the file that I'm going to upload is Athena. I think is the in my document. I'm going to upload it. So this key I'm uploading, or this file or object I am uploading over here. So this concept and you can plan your option here. And guys, this thing we already discussed. So per object wise, you can plan. So this object I want to store here. other object I want to store here, other object I want to store here. So per object wise, you can plan where you want to store, which option or which class you want to use, right? That will be your choice. So let me upload by default option. So my file uploaded it. So the file that I uploaded here is pure raw data. I show you already. There's a file I uploaded. Now, interesting thing is, let's say we collect a log or some other information from my team and upload it here. Now my requirement is I want to do some analysis on the top of this data. And you guys know we can't do the analysis without metadata. So for getting the metadata, I have to go to Glue catalog. Or for analysis, I have to move to Athena. So let's first go and move to Athena first. Okay. So let me open search for service called Athena. Okay, guess here, query data Declan S3. That's the use of Athena. Okay, so I'm moving to Athena here, and let me move up to Singapore. You can use anywhere. I'm using Singapore right now. Okay, so this is Athena. It's a fastest query services. Okay, petabyte case you can actually do in S3, and you don't require a third-party warehouse or data warehouse. Okay, DWH you don't need. Okay, otherwise normally what happens if you want to query this big data, normally we have to load the entire data in our data warehouse. So data warehouse is again one concept. Again, we have product in the market for data warehouse. Okay, for example, if you go to AWS, they have their own product called Redshift. If you go to normally they have Teradata and other products also. Oracle also have their own data warehouse product, very highly priced. Where to store data, then you start querying for analysis. Here we don't require any product, right? They directly go to S3 without loading the data from there. They can analyze your data. That's the beautiful thing about Athena. Okay, so we can do it. So let me go and get started. Start the Athena. Okay, now maybe guys here you can see very clearly. You will see a word called data source. Obviously, you have to tell Athena where is your data source, from where you want to go and analyze your data. So for my case, in my data source is S3. So obviously, you have to connect Athena with S3. How? So there's option guys called connect data source. Okay, so I'm clicking here on the connect data source. It open this page. And now here they're asking you I will help you to connect your S3. Okay, this is a by default option, but recently, guys, they have added one more new option that to connect Athena with other data sources. Okay, so S3 is Athena is actually meant for S3 now, but nowadays they support other data sources also. So if you click here, you can see, guys, these are the data sources they support. They support CloudWatch Log, DocumentDB, Redshift, Matrix, Redis, and others. Also, you can create your own connector also by Lambda. Okay, so these are the things they support extra. It means your data maybe in MySQL, Athena will go there and search in the MySQL. Okay, maybe as such we might not have need, but maybe we might have. So there's extra support they have. But here our focus area would be in S3. So I will move to S3 only. Okay, and now here there's asking on, which means we are telling my data, raw data would be in S3. Okay, and I'll tell you in a minute S3 in which bucket I have data. Okay, and next thing they're asking on, obviously mostly we store raw data in S3. So where is your metadata stored? So here my metadata store would be from Glue data catalog. Okay. They have other support also, Hive Metastore also. Okay, so you can set up your own Hive product, right? Apache open source product, and store the meta store there also. But Glue is a serverless. They will manage everything for you. You don't have to worry. So let me go for AWS Glue Data Glow. So for metadata, we're going to use this one. So let me open Glue also in parallel. So there's a Glue service. Okay, I'll open this, and let me again move to to Singapore. And as such, guys, if you click on the databases, okay, some sample is there, maybe for some other reason. As such, there is no things that is created by us, so there's no table created for us. What I mean by this table, we'll discuss in a minute. So Lincoln thing is like clean, nothing is there just for a while. Okay, so this is a glue data catalog. Okay, so so I selected in my Athena. I would like to pick the data from S3, or I stored my metadata or manage my metadata in Glue data store for Glue. So Glue data catalog. That's what we plan. Okay, so let's click next. Okay, so so there's this concept called crawler. Right now we don't have to discuss right now crawler here, or maybe add table entry. Let me go by default. Okay, so I don't want to discuss what is crawler here. So they take me to Glue actually by chance. Okay, to create something I already there. So we guys will discuss about why they come up here. We have to create something, right? So let me go here first. This makes more sense, because otherwise crawler we have to explain some more extra concept. So they ask me to enter table and schema manually. Okay, so what I mean by this. So let me continue. You come to know what technically I'm talking about. Click add. And guys, here they're talking about a pretty simple thing. They're talking about so understand one thing, guys. If you talk about any analytics tool, okay, so my requirement is what? My requirement is I want to go in this data, and maybe I want to ask, can you tell me the salary of women? Or can you tell me the total number of employees that has a good remark? This is called query or maybe analysis. Okay, so normally, guys, mostly in any of the tool in the market who help you to analyze a query, obviously from some data source. Here is S3. Okay, so in the market we have one standard format for query or analysis, and that format is called SQL language, structured query language. Okay, so SQL is very standard in the market. So almost all the tool, even though if you go to Excel sheet also in your Microsoft Excel, they also have SQL support. So this is very standard in the market. So any tool, any program who want to do some query analysis, they support SQL syntax or SQL concepts. Okay, and in the SQL world, right? Normally, what we do, we normally arrange our data in this kind of boxes that is called table. And in table, we give a column name here, so ID, name, salary, remark, and here we store our data in this format. So this is called table. And normally, guys, we store table in one big box because we might have multiple tables, because every table has one data from one file. Okay, so for example, this is my one file. So for this file, I create one table. I have more files, more table I will create. And why I have to create more table? Because that file have a different data. They might have 10 different columns and different kind of data there. Or maybe this is the, for example, employee data that will have a maybe customer data. Okay, but all the table, guys, we group into one box that is normally known as database. Okay, so here that's what they're talking about. They're talking about do you want to create database? Okay, create new, or you already have some database. So they asking you that that you have to create a database. So I say obviously yes. So I'm giving the database names, for example, Linux World database. This is database I am creating here. You can think database like a folder. So do you want to give a table name? So let's say this is my employee table. So this is my table name. Okay, and here they're asking you, can you tell me the location where data is located? Obviously, they're asking me about S3. Okay, okay. If you also see here, they're also giving example about partitions also. So you can also manage data per year, per month, per day basis also. You can also go in this way also. But here I'm not going for that example. Just wanted to explain you in very high level. Okay. So what I'm going to do, I'm telling this guy my data is located in this particular, let me go here and my data is located. One minute. Maybe let me go here, and normally, one minute, please. Copy the S3 URL. So now they give you here also. So I'll tell this guy that my data is located in this URL. So go to this URL and you will find my data, even though again give you file name also. So maybe here better would be, let me give the file name also. So I'll tell him this is the location where my data is there. It means my input data is there. Okay. So technically what exactly I'm doing here. So I have this data. Where there is data file located, I'll tell this is the location it is located. Okay. But motto of this data, why are we using Athena? Our plan is to do analysis on the top of this data. And for analysis, we have to create a table. Table means it's not like actually this kind of box they create. Table means here we are going to provide every column a name or field name, typically known as schema or metadata. So when I say table we are creating, it means normally we are going to create a schema and the metadata. Okay, but obviously schema, metadata, or table you have to give a name. And here in my case, I give the table name called employee table. Okay, that's what guys we have done here. Okay, now next. So it is a format of with folder name. They not a valid folder location. Here you have to give a folder name. I don't know if they give the name of file also, but let me give the folder name till here. Now here they're asking you when you upload this data in S3, what is format of this data? This is normal text file, CSV file, and guys, in the big data world, there's lots of different formats available for for optimizing the performance of read. Or maybe write, normally read. Okay, it's called Parquet or Avro, lots of different format available. Our file is simple format, it's called CSV format. Okay, so here I select my file is into CSV. They are not text file or tab separator file, is a comma separator file. It's not JSON, Parquet or ORC. But these are the different formats they support. Anybody here are from Earth learner? So in my upcoming class of Hadoop ecosystem or big data ecosystem, we'll talk more about Parquet or ORC and other format types also. What the difference and when to use what. Okay, but right now this file is CSV formatted, means comma separated, means every column or every data is comma separated here. Okay, and mostly data set or raw data mostly come with comma separated file. Okay, click on next. And now guys, here they're talking about you're going to add a table. Technically the meaning of table is to create a column name or schema or the metadata. Okay, so in your file, tell me what is the first name of the column. So let's say my plan is to give first column name is ID. And what is the value of this? I know that is integer. Their technique talking about data type. Okay, so do you have more column? I say yes. What is the next column name? So I want to give my next column name as employee name or name. I know the value of this guy would be string. So the data type. Again, I have one more column, and according to me, this column is salary. The column time obviously is integer. Why? We can go for string also. But if you go for string, if you want to do some analysis on third column, related to do mathematics, plus, minus, divide, average. So you can't do on the string. You have to use integer. So you should know your future plan also. If you do some kind of plus, minus, you have to use a data type called integer. And we add more because I have one more column. So let's say this column name is called remarks. You can give your own column name. And obviously, let's say this is a string data. And I know my data contain this field because I know about my data, right? I know about my data. So this thing come up. So finally, what I did, okay, I created a metadata. Guys, right now, I am into the page of Athena, But this information or this table or this metadata, behind the scene, they are going to create in a Glue data store. The Glue data store is the one who actually stored this information. So if you go to Glue again, where's Glue? If you go to Glue again, if I refresh, if you refresh, okay, there's no tables as such, there is no database as such because we haven't created. Okay, so either you can come also here, you can create yours here also, and then attach there, but from there I'm creating to this guy. Click next. Okay, here they're talking about the partisans. I'm not going for this topic. Obviously, we are not in purely into analytics class, but I think you guys might get the high level idea of partisan. Okay, and now finally create table. Okay, no output location provided. No output location provided. What I mean by this? Okay, that this error is normally come because whenever guys you first come to Athena first time. Okay, right now I'm in Singapore region. If you come to Athena first time, okay, here they talk about in Singapore. You see what have they provided? They also created me SQL query here. So here they talk about if you are running, again let me explain. Right now I'm doing everything graphically, but anybody who know SQL, if you want to create a database, we have a create database command. If you want to create table, we have a create table command. Okay, so behind the scene guys in SQL, whatever you do, okay, we have SQL commands. Good thing is recently AWS added this kind of graphical portal. Okay, you do without knowing the command, without knowing the SQL queries, you can create everything. But behind the scene guys, they run the command for you. How I know? If you go to Athena page again and see guys here behind the scene, they created this command for you. So you know SQL, you don't know SQL, that's okay, but they create this command for you. But anybody who know by chance SQL, they can very easily say they are going to create a table with this 4-field ID, name, salary, remark with integer. Okay, and in this table, they are going to feed a data, okay, from a location called this one. Okay, this one. So this is the guys, this query they automatically create for you. So when you guys running creating table, you're getting this error. Same thing if you run also from here, you also get the same error. Why? Because by chance, if you are the first time using the service in particular region, you have to set up this. Okay. So I think this is the reason why they're giving this error. So they say whenever you run any query, maybe create database or create table, they give you some output, and I am the tool just to analyze or creating something for you. But any output come up, okay, I have to store somewhere. So where to store? You have to give me the location where to store. So you guys have to set up this thing only for first time. Okay, so whenever Athena give you any output, you have to store somewhere. So you have to set up this thing first time. There's a link here. Or maybe in the top in setting also you can go initially to to set up this. So anything where will go, but here I have to click here. So you have to select where your result will go. And normally guys you store the result in S3 only. Okay, so what I'm doing here in S3, okay, in the same bucket, I'm going to create one more folder just for output. I can create anywhere else, other folder also, other bucket also, but this is a folder I'm going to create and where I will keep all my result of the thing. Okay, and I'll again go to Athena, where it is. You can tell, okay, there's option select, and I'm going to put here in a folder called output. So this is a folder I'm going to use for my result. There's one time setup to do. This I think this is the reason why they are failing. So I can't see. Yeah, see. So I minimize the font. Let me save. Yeah. Okay. So done. Now again, either you can click here or you can go to this graphical way, whatever you feel like. So now I think it should work. Okay, now, yeah, it's work. That's the reason. So technically, behind the scene, they create a table or a schema for you. For this, they use this command. Long back, guys, when the glue come up, or sorry, this Athena come up, this command we have to write manual here to create this, but now they give this graphical command to do for you. But maybe you can see some word here. They say, I know your data. In data, every line is a record. Every record is comma separated, right? And this is the way we manage here. So we say here, every field is delimited by comma. Okay, and this format, every row is a new line. Okay, this concept called SERDI. I'm not going to explain SERDI here, but technically you might see some Hive or Hadoop, something they're using library. But right now I'm not discussing what is SERDI and other things. Okay, but this is the command behind this in the use. So finally, my database created and table created. Okay, but understand one thing, everything here I might have created from Athena, but this table, this database, or entire schema is actually created in the Metastore. That is Glue. So how can you check this? So if you go back to Glue again, okay, and if you refresh, you can see here that this guy's come up. But let me again refresh. So you can see your database come up here. If you go inside the database, in the database we have a table. We click on the table. This is the table we have created, and this table is pointing to this location where the data is. Okay, and if you click on this table, you can see more detail. So in this table, we have these 4 values. This was schema. Okay, and this table, it is very clear that every value wherever we have is comma separated. Okay, it's comma separated. But technically, it is just a Metastore. This guys doesn't contain any data. Data they are pointing to S3 is my data lake. Because in the bigger world of big data, this is how it works, right? We store data somewhere else, we store metadata somewhere else, or analytics tool is somewhere else, and everything is connected together. One of the reasons is because data is so big, there's no good reason to transfer data here and there. So in the big data world or this kind of world, this is how we manage this. But from here, guys, you can do some more thing. You can add it as schema, means you can add more columns if you think you want to add or rename. So all the things you can do. So guys, here the use of Glue come up. They have a lot of things Glue can do for you, but I always see in this training, we are not going to discuss about ETL operation, but this is what I want to show you. Okay. So finally, according to our diagram, we have set up Glue data catalog. Okay, that's for metadata. We have data in S3, and that's all. Now the role of Athena comes in play. Okay, so what is the use of Athena now? Obviously to query. Okay, before this, in Athena page, let me again refresh. In the Athena page, you have to first select which data source you want to query. So I want to query this data source. Which database? This database. Okay, so just select your database, and guys, as soon as you select, automatic table name come. Okay, so if I select the other database, different table come up. If I select other database, there's no table there. Okay, so this data source we have created, let's go on my S3. Here we select this database that has this table, and if you see this table, they have this column. Okay, where this information come from? I'm in the Athena. Where this information come from? This information behind this and come from obviously from Glue. So they're fetching from the Glue or maybe from the Hive we can think of. Okay, but now what I want to do from the Athena, analyze, and for this I have to write a query. So there's a plus option here. Click it, open a new page. They give some examples also for for query. Okay, and to get something. So I don't need this example right now because most things we have done already. click, and let me write the query. And one of the simplest query, guys, in SQL is if you want to read the entire data, then the command called select star from table. And here table name is called what? Is employee. You have the simplest thing, right? Star means go to this table. Table means this this file, obviously in the S3, and retrieve the entire data. Read all the column and all the rows because why I started. Okay, and now I run this. What do you see, guys, here? Okay, entire data S3, they process, and what a result they have, they will show you. Obviously, guys, this data is, if they have terabyte, all the terabyte data result they show you. Obviously, this is not the good query to run. Okay, but this data is so small right now. I can run it, and in the last, if I run, this tick come up, and in the last, you can see result come. Interesting thing here is, right, now, even though I had a raw data, but now my Athena know the format of my data. They know this is this is salary. Okay, how they know? Because here they arrange salary in the salary column. So as a result, it look like my data stored in this format, but technically the last one is raw data is stored in S3. The first one, top one, is stored in Glue. My Athena clubbed together and so many here. Obviously, guys, data is big data, petabyte. You won't want to see it. Everything here, it will hang up or maybe might not work. So we use Athena for analytics, right? And it's something like this. For example, I just want to look only for salary. So here, instead of the star, I can say, I know my column name. So just go to salary column. Okay, just retrieve only the salary part. So the processing here, they only retrieve the salary. And why I want to retrieve salary? We want to do average, or I want to do sum or count or something like this, or maybe top 3 salary, top 4 salaries. Okay, for example, there's functions here in the SQL, guys. For example, sum is one function. Typically in SQL world, we have, if the Athena also support the same function. So what do you see? Okay, they show you the sum of the salary, or maybe you want to do average, right? They show you. So interesting thing, guys, here is this query I'm running Athena. Okay, Athena go to S3. Let's say this data is terabyte. Without loading data from S3 to Athena, entire process happen in S3. Whatever the way they arrange the system for us. Okay, and and only a result come back to Athena. Okay, so guys, see here, technically, if you talk about the network process, your network, you don't have to transfer the entire terabyte data here. My data is there only. Okay, I don't have to load in my other data warehouse or the tools. They give me a result back. That's one of the cool thing and interesting thing of Athena. Okay, and obviously they're taking the help of S3, no doubt. Okay, otherwise this class is not SQL, but if you know anything about SQL, for example, very quickly, if I say here star again, show me all the data. Okay, where for filtering, where let's say name is Vimal. So Vimal is a name, I can put in the string. So they will show me all the result of Vimal. So this is called query. So this will come up. And if you just want to look the remark of the Vimal, so here I can say only show me the remark. Okay, and then you can do the remark. Very simplest query, but anybody who know about partisans or view or aggregation or group by, order by, join, inner join, left join, right join, almost everything you can do it. Okay, so almost all the things that you do on the top of data warehouse or database world, or especially I say not database world, about on the data warehouse world or analytics world, almost all the operation you can do here. Okay, so point here is not this query. Query is pretty simple. I believe in 2 hours anybody can learn SQL in detail. That's the fact, right? The important thing is the way they arrange and way they're performing. The interesting thing is they say we are performing everything in our storage world. You don't have to move your data here and there. That's the main key over here. Okay, so guys, this is about Athena, Glue, and all the things. And you can save your result. You can create a different table. View also is a concept they have. What is view? I'm not going to discuss right now. So these are the guys core concepts of this one. Okay. By the way, guys, I told you already this concept is as such we don't have in our CSA or plus in developer. Very high level concept is there. What is the meaning of this tool? But I just try to show you this kind of practical. If you can also go and perform. Sorry, this kind of practical. So upload your data, maybe your log file. They are raw data, and just create a schema in the glue and start analyzing. Right. So that's what you can do. So guys, this is one of the topic I planned for today. Okay, one more topic I have somehow related. Okay, somehow related. Topic is called CloudWatch log. Okay, so what is the idea of CloudWatch log? So idea is something like this. 1 minute. So what is CloudWatch log? Very interesting concept, guys. You will definitely like this concept. Okay, the way I'm going to show you the demo. Okay, but what is CloudWatch log? Okay, so guys, before this, I have one quick announcement. And this announcement, a lot of guys keep on asking to me from last couple of weeks. Okay, so soon now we guys plan to launch this. So what exactly we are going to do? According to guys current research in the market, obviously guys, now almost every industry run the entire app or workload on the cloud. That's the fact, right? Or cloud computing. So nobody can deny this. This is a fact, right? So everybody, maybe small startup company, small organization, or maybe big companies, they purely depend upon the cloud. Now it is their choice which cloud they want to go. Obviously they will want to go public cloud or not private cloud. Private cloud is more like managing on premises everything. So they want to move to the public cloud. Now choices may be Google Cloud, GCP, or AWS, Amazon, or Azure, or for Microsoft. Okay. Some time back, okay, normally one organization or one industry try to stick with one cloud. So let's say if you have XYZ company, XYZ bank, and let's say they say we start practicing AWS, so put everything in AWS. Or we practicing Azure, let's put everything in Azure. Okay, but I recently, from last couple of maybe months, or recently, or if you talk about the talk of the leaders or the management guys of the industry, and they're talking about the future also, what they're doing here, what they're doing now, they say it's not good to stick with one cloud, guys. Because if we stick everything we do in with one cloud, guys, so technically, finally, we're stuck in an issue called vendor lock-in. Okay, so it's something like if companies purely depend on the and Microsoft Windows from initial days, and they're running everything in the Microsoft Windows on server, so they're stuck in one vendor. So in anything in the future change policy in the Windows or servers or Windows, you're stuck. you have to follow those policies because there's no option, guys, because this is how your Intel team has been trained on. Okay, so you have to follow this policy. The prices, something changed, model change or business. So vendor locking, none of the company like. Okay, so nowadays what companies doing the practice, and they started already, and that is actual future from now onwards. Okay, so what business guys or leaders of the company saying, we want to create a model. We don't want to use cloud, no doubt, but we want to create a model of our company or industry or a bank is we don't have to stick in one vendor lock-in. Okay, plus there might possibility some feature of AWS is great, but same feature Azure also have, but they are cheaper in price. So for that feature, I would like to go for Azure. But some part of some store my AWS might be good. They might not be available in Azure at that level of performance. That feature I would like to go for AWS. Okay, or maybe some other part of GCP cloud is very great. Maybe that's very cheaper. Okay, so they're cheaper in resources compared to AWS. So in my company, we have a lot of testing and development jobs. So all the testing and development job we can do in GCP cloud. or the analytics job, they may be good in analytics part. For example, I do in Azure, or the personal workload I will do in AWS. Okay, so so we are actually trying to organizing the cost and other management part. And plus, we're not stuck in one cloud. Something happened in one cloud. Okay, so we have option other cloud open. We have a practice on this. Our application maybe in staging environment or pre-production environment might be there in that. So we can very quickly switch between the different vendors. Okay, so guys, the future is, and this practice also already started in the market on industry, is multi-cloud. So I highly recommend. Okay, by chance, you guys know Power Cloud. You guys are now good in AWS, but I highly recommend trying to switching yourself and thinking in this way that multi-cloud is the future. Okay, this is one thing. But biggest challenge, guys, in the multi-cloud and in the market is AWS has its own API, own command, own portal. GCP has own command, own portal, own API, own SDK, own Boto library, or something like this. So everybody has a different thing. So, challenge for this organization is, right, they can't train the resource again in GCP or AWS or Azure for same thing. But maybe here we can launch an instance via VM or instances here, but commands different, portal is different, look and feel is different. So training all the Intel team and employees for all the cloud will be big challenge. So we need some solution, okay, that being a generalized solution, I can say. Okay, so one tool or one interface I need. Okay, so my team has to know that only one interface, one tool. There's a specific one tool. But by this tool, they can deploy the workload either here or here or here. Okay, so they don't have to do much. They don't have to change much. Okay, so let's say they want to launch a VM. Okay, just they have to update, launch the VM Azure, or launch the VM Azure AWS, or launch the VM GCP. Without changing the things, without changing the code, without changing the commands, maybe. Okay, just by telling where to want to load, launch this workload, and accordingly, my this tool automatically go there and launch it. So without knowing AWS, GCP, and Azure much, how they work internally, what the command they have. Okay, this tool will gonna manage almost all the cloud. Okay, and there's a lot of product for this in the market, but nowadays one of the great product who doing very well, and that tool has a great demand in the market. Especially this demand already we had for this tool, but because of the this changing in this paradigm of multi-cloud, the tool demand increased more already. The tool that I'm talking about is Terraform. Terraform. Okay, so you guys might know Terraform, and a lot of guys keep on asking me from from a couple of weeks to have start the Terraform training. So what I did, guys, we are planning to launch not only the Terraform training, because Terraform training, guys, you guys might a lot in the market. Okay, might not be at that level that as a pure industry guy you should need, but we are planning to launch a Terraform training in such a way that will actually cover actual design pattern, planning, strategy, and plus use Terraform to have multi-cloud setup. So maybe this is the first time happening in the world that we are launching the Terraform for the multi-cloud. Okay, not only for AWS, not only for Azure, it's for multi-cloud. And it's basically 3 main cloud we have in the market. So Terraform, how to do multi-cloud management using Terraform on all the top 3 cloud provider, GCP, AWS, and Azure, with our best practices, with the best scenarios, right? And that's what we have tried to. We created this kind of program, and maybe most probably maybe tomorrow, day after tomorrow, we'll launch this program. This training maybe will go per in weekdays in evening time. Maybe in May we are launching this training. Anybody, I suggest you guys, because you guys are cloud guys, so very much core and useful training, for your grooming part, helpful for you. So it is purely Terraform training. Everything we're going to start from basics to all the thing at once. Okay, but the use case would be multi-cloud management, the proper design, pattern planning, use cases, best practice scenarios, and that's what we are going to discuss it. Plus, it will cover all the concept of Terraform, global training also. If anybody want to go for global training examination also after this, they can do, because it will cover everything over there. Okay, so this is guys one quick announcement, and that's the reason guys I opened one of Forrester report about the multi-cloud. If you want, I'll share this report to you. Okay, and this was guys, they're talking about what I was telling you. Okay, right? So firm avoid vendor locking. They want to move to multi-cloud deployment. Okay, 70% of firm agree that they're going to want to avoid with vendor logging to a single vendor of the cloud. This is the one point. Otherwise, they have a lot of points why company and organization want to move to to the multi-cloud. Okay, so the Forrester report, and there's a future. There's a future. Okay, so we have to accordingly plan it. Okay, so there's one small thing. So let's move, guys, to the next topic for today. Topic is Cloud Watch Log. So as a plan, plan is something like this. Okay, let's say we have one instance. Let's say we launch the instance in EC2, or there might be possibility your instance is running in on-premises. Let's say they're running in your virtual box, or maybe in your on-premises. And let's say this instance is running with web server, or let's say they are running with web server or database server. Let's say database server. Okay, but you guys know normally it's very common whenever you run any server, they always generate a log. Okay, log. Okay, and not only log, guys. Okay, there's one more things we have. Normally, this server or this service also generate metrics. Metrics. Okay, log means already I discussed, right? Whenever any client hit to the server, for which IP address, which time, which file they want to access, so they store in a file called logs. Okay, and what is metrics? Okay, metrics is you can think at this point in time how much CPU they are using, how much RAM they're using, how much IO operation they're doing, how much network bandwidth they are using, and a lot more. Okay, so it is more about checking the current performance of the website. If I want to see this, obviously, maybe because of auto scaling. Okay, if I see this instance using more than 80% CPU, so I can add one more web server behind the load balancer. Okay, and maybe some other purpose we can use. Okay, so logs is a different thing. Metrics is a different thing. Okay, so what I want here, technically, let's forget for a minute about metrics. Okay, so we have thousands server running. Some of the server running in AWS cloud, some server running in in a local on-premises system. Everybody generating a log. Okay, and what is use of the log? I told you already. Use of the logs to analyze what is happening in the current server. Are they down? Means they are having the DOS attack, or which page use access more, or maybe you have 10 products, which product page trends is coming more. So accordingly, we change our campaign. So there might be multiple purpose why we want to do analysis. Okay, but now the challenge here is this server has their own log, and normally, guys, log is stored locally in your own local hard disk. So this server log is stored in their local hard disk. This log is stored in their local hard disk. So 10,000 server running, so everybody is storing the log in their hard disk. Or maybe they are the container of the Docker or pod of the Kubernetes. They store their log in their pod or in their container. So technically, log is stored locally. Okay, and if the log is stored locally, so going to every computer to retrieve the log to analyze is very hard. Okay, so normally what pattern we follow? what pattern we follow? Normally in all the server, whatever logs we have, okay, we create one centralized storage. This is also known as centralized logging server. logging server, sometimes also known as a remote logging server. So we create some remote login server, and what we'll do, we'll tell to this instance, let's say this IP1, and say all the logs that you create store locally if you want, but also start syncing to this centralized log. For example, this IP is 100, so start sending this log to IP 100. Okay, same thing I will tell my this system running somewhere, maybe in my local system, my laptop. I say yours ways, if you don't want to store locally, don't store, but start sending this log to some centralized remote logging server. Why? If all the logs store centralized, it's like a backup, first of all. A second benefit is, now any analysis tool, I don't have to ask all 10,000 computer. I'll ask, just go to this single centralized computer, you get all the logs. So what are logs you want to retrieve, and go and retrieve and do the analysis. So here in my case, I can tell Athena, go to one single location, retrieve the log, and and start analyzing, or whatever you want to do further, you can do it. Okay, so the point here is Athena, analysis, till now. Okay, the interesting thing is how to create this centralized logging server. So for the guys in the market, there are a lot of product available in the market to create a centralized logging server. Even though anybody who know Red Hat, so they have a product called RSysLog. So RSysLog is a product in the Red Hat. Okay, using this product, you can create your own personal centralized logging server. But if you create your own, again, you have to manage. Okay, that's what I don't want. So I want somebody create for me and they will manage for me. Obviously, I would like you for cloud managed services. So if you go to cloud managed services, AWS, so they have their own centralized remote login services, and name of the service called CloudWatch Log. And guys, there's a use of CloudWatch Log services, and it is this service who help you to create a remote logging server. So if I very quickly go to CloudWatch. Actually, CloudWatch is a big main service. Under the umbrella of CloudWatch, there's a lot of small services, sub services we have. So we click on CloudWatch. Okay, so it's used for multiple purpose. Okay, but here I'm talking about CloudWatch logs. Here, logs. That's what I'm talking about. So this service is to store log, right? Also analyze. Also, we'll see what I mean by analyze. But here they store the log. Store the log means this is a centralized computer. Managed services you don't have to manage, right? And highly scalable, durable, so you don't have to worry anything about. So AWS will manage everything for you. Okay. So this is the one. There is a log management tool. Okay. So the only thing is that we have to do. We have to do CloudWatch log service is there. Okay, but your log actually created in your local computer. Okay, in your local storage. Here in the issued in the local storage, who will get this log and upload here? Who will get this log and upload here? So in this kind of world, in this kind of scenario, CloudWatch is one of the products in the market. We have other also like Datadog, Splunk, and other products also we have in the market for same kind of functionality. Or here RSysLog also. Okay, so in this scenario, if you want from your instance, okay, you want the log that is created by web server locally will fetch and upload it in the CloudWatch. So for this, you have to run some programming where in your local computer. And this kind of program is normally known as agent. So CloudWatch has their own agent that you run in your instances. And ask the agent, okay, to collect the log for databases, for web server, or maybe other files, or your local systems, or your boot files, or whatever guys you have. Agent will go and collect the log and upload it to the CloudWatch. After they upload the CloudWatch, so this will be a centralized page, okay, where all the log is stored. Okay, then we use some third-party tool or maybe Athena, or these guys also have some way to analyze also. A Merter also. What do you mean by analyze a Merter? We'll discuss. When I go for how to integrate SNS, we will see how what I mean by this. Okay, so this will do further thing for you. Okay, but obviously if you don't have a centralized log store in central location, you can't do further thing. Or maybe after a log is stored here, we can also ask this log to go to S3. Okay, so I can tell I can tell my web server to store directly in S3. we can create some program extra. There's a different point. Okay, but better way would be the management store all the log in centralized system. Now centralized system will decide where to send the log. Keep it here, or maybe some of the logs send to S3, or some of the log will do some more things. That will be further choices, and that's what guys they're talking about. So they have a way to export the log to S3 also if you want to. Plus, but technically they store your log in this service, so you can do further analysis and do some more. So CloudWatch log is a centralized logging system where you can upload the log. Okay, for this we have to put the agent. So guys, by chance, according to CSA, we have just only this level of discussion we have, but I also want to show you the demonstration of this particular topic. Obviously, it takes some time. So what I'll do, guys, we have one interesting thing to be noted here. This is the reason I take this example here. We have an agent available, so we can install the agent in our local computer also. So it means if I have a virtual box running in my own premise on my laptop, they also generate a log, right? So I can also upload the log of this guy, okay, directly to the CloudWatch log. So wherever you have the log, okay, any of the environment, you can store everything in a centralized CloudWatch. So there's also one great benefit they have. Okay, so I'll show guys this demo tomorrow because on the top of this demo, I will show you how to integrate with SNS and the CloudWatch alarm. Okay, so it's something like this. When any kind of activity happen, maybe somebody is doing attack or some kind of error come up multiple times, we will send notification by SMS or email, something like this. So this kind of demo I will prepare here and see how it works. Okay, so that's all guys, multiple things we discussed, implemented and tested, working good. And this concept with some more things we will see tomorrow. So tomorrow at the same time, 6:30, we'll discuss. Any question guys, if you have, you can ask me. Yes, just in metadata stored is in Glue. No, Narayan, there is no serverless service for the Splunk. Splunk is a different tool from different company. So there's no link of AWS with Splunk. You guys might find some instances as AMI that give you Splunk installed, but it is a a different product altogether. No, Nitesh, Athena is not like a BigQuery in GCP. Okay, it's not BigQuery. BigQuery, you can think it is like a data warehouse. Okay, you can think in this way, something like this. It is not a BigQuery. So, Piyush, actually, SQL is the actual query. DynamoDB is not a query language; it is a database. We have hundreds and thousands of databases available in the market. Okay, database in the market. But what I say, but the way we query those databases, every database has their own own purpose purpose to store their data in their format for their use cases. But normally we use SQL way to query it. Okay, so DynamoDB you can't compare with SQL. SQL is just a way to query any of the databases. Mostly database support SQL. Chetan, you say this can be done with MySQL. Understand one thing: if you have 10 terabyte data, if you want to do this thing with MySQL, you first load the entire 10 terabyte data from S3 to MySQL first. See, guys, how much time you're gonna for just for some operation, right? This much time gonna take, right? So this is one big thing. And second thing, MySQL doesn't support this much of big data. MySQL is only RDBMS system. They are not the analytics tool. What I mean by this, maybe in some of my further training we might discuss. Okay. Okay, so there's big difference between hybrid multi-cloud and multi-cloud or hybrid cloud. Okay, this training that I'm announcing is a multi-cloud training. Recently, guys, we have done with hybrid cloud training also. So this is not the hybrid cloud training. What I'm discussing today, it is multi-cloud training, pure multi-cloud training. So no prerequisite, guys, for this training. There is no prerequisite. Okay. No, actually, yes, they are not using Grafana Prometheus. These are different tool. They have their own internal tool they created. So they are not using Grafana or the Prometheus for these things. Okay. So Jagnesh, as such, EKS and Fargate might not be, might be some of the part of ECS definitely we cover here. Uh, Fargate or EKS we can also cover, but again, this training will go very long, unwanted, right? Because for EKS and Fargate, I have to first explain what is Kubernetes. Okay, so might not be possible. Yes, Mahek, you are absolutely right. This is one of the good use case of ambassador design of multi-cloud. You're absolutely right. So this use case that I was talking about. So let's say this web server is running inside the container, or I say pod. So I have to put agent here who will collect the log and send to centralized system. So in one pod, you can run two container, one for web server, one for agent. Okay. So what Mahek you are saying, you're absolutely right, is a design pattern of multi-port container that's called ambassador. It is very complex to add append extra column. Actually, Sobit is not good practice as it's not complex. It is not good practice to add extra column, because if you talk about big data world or data warehouse world, uh, the planning is very important. Okay, so harder for me to explain you right now. Maybe in my this kind of topic I will explain you. So if we say you want to add extra column in your big data or data warehouse or this kind of solution, it means your planning was not up to date. And this is a very one of the complex operation you're gonna do, and that's only good accurate. Adding the column in RDB-based world, that's okay. This is the very common thing we have, or some of the NoSQL, that's okay. But in data warehouse, it is not at all okay. We can do it if they provide the support, but it is not at all the recommended way. So Vasi, I think I already explained to agent. Agent is one who will run in your instance, collect the log, and send it to the centralized system. That's called CloudWatch log. I think Nikhil, you're talking about CDN. I think CDN. I think Obviously, it obviously improve file access, right? CDN Cloud Front we already discussed. It will definitely improve the access of file if the file is there in the caches. Okay, so if file is already there in the caches, so it will very highly improve the access of the file. So that part we discussed in our Cloud Front already. Rahul, all the best for your EX 295 examination, right? All the best. How Athena program run in S3 object storage? Actually, they have some internal support from S3. Okay, they have native support. So there's one more concept called S3 Select APIs. So they might use S3 Select API. What is this? Maybe I give you a very high level idea, Balwin, when Venkata, tomorrow. Okay, so it is native support by S3, and they provide this support in the terms of Athena properly, so anybody can use it. It's called S3 Select. So even though if you search S3 Select, is one support in S3 that has this capability that Athena directly give to you. Yes, Subhash, you can say Athena is like a not exactly BI tool. Is very much have lots of features. Business intelligence tool like Tableau, but it's not like that much. But yeah, basic level analytics that you normally do in your big data world or data warehouse world, that much capability Athena has. Okay. So what are you asking? Data Guru or Glue and other things, data crawler. I'm not discussing. I know Glue is a big service, big service. So not possible again to discuss everything here. Yes, so today, guys, we have Python class and ISRI is a very important class because um, uh, we are going to start REST API today. Okay, so so that's all, guys, for today. See you tomorrow with some more new concepts. Bye. Take care.